Okay, so what we're going to go over here in this video is the multiplicity of zeros, right? So if we see this function f of x, right, we see the graph or the function here. We have a function that has three zeros, one at -1, one at 2, and one at 3. Right, so here we have in factored form, so it makes it easy to tell. And as well, we have the graph paired by it, also easy to tell. Now it has three exponents, a, b, c. So I'm gonna kind of play around with these exponents to see what happens as I increase them. Right, currently they're all set to 1. Right, meaning they have a multiplicity of 1. They're linear factors, is what we call them. Okay, now if you notice, as each one of these crosses the x-axis, right, it just goes right through it, right? Almost like if you zoom in closely, it just looks like a line, right? It has this linear behavior where it crosses the x-axis and it just goes. Right, here, same at 2 and 3, right? They're all set to a power of 1. Right, so when it has this type of behavior, what we have, it has multiplicity of 1. Right. Now I'm gonna change this first one right here, right? So currently I have degree 3, and we can tell by its general shape it is an odd degree. Comes down from -infinity, has this kind of local behavior, but then at the end it goes towards infinity. Now as I change my -1 factor to have a power of 2, okay. So a couple things happen here, right? Now notice first, what doesn't change is the behavior around 2 and 3, right? The x-intercepts 2 and 3, right? Those still have that same linear type of behavior. And now the overall shape has changed because by increasing that power of a from 1 to 2, we no longer have an odd degree. We no longer have a polynomial degree 3. We actually now have a polynomial of degree 4, right? And we can see here 2, 3, 4, right? You can just add those exponents up, and that gives you the degree. Okay. Now notice also the behavior at -1, right? With a being 2, changes as well, right? Before, when it was set at 1, it just kind of touched or ran through it like if it was a line. But here, that's not what happens, right? As we go through here, it goes down, it touches -1, it does become 0, right? We could see here, it is a point on the graph, but then it just bounces right back up, right? So it doesn't go below the x-axis, excuse me. It touches it, then it goes back up. All right, now here, this is a behavior attached to even numbered powers, right? If I put it at 4, right, we get that same thing, right, where it kind of touches it, then eventually bounces back up. You switch it back to 2. Right, so when we have something like this, we have it's a root with multiplicity 2. Right, and as we see, if it has any even number multiplicity, it will have that same behavior, right, where it just touches it and then bounces back up in whatever direction it was, right? So here, right, so here, if it were in the opposite direction, here I changed the value from 1 to 2, and we see in both of these multiplicity 2, it kind of touches the x-axis, then it bounces back in whatever direction it is, right? It doesn't go across the x-axis, right? It simply touches it once, then goes back in the direction that it came from. All right. So those are even numbered powers. All right, now let's take a look at an odd numbered power. So I'll change that A1 as well. Excuse me. So here I've reset my I reset B and C to have a power of 1, and now I changed my power of x plus 1 to be an odd number, right? Now notice here, right? Now it's a similar behavior when it was 1 in the sense that it goes through the x-axis, right? It continues on its way. In this case, it started from -infinity and then comes up, right? Increasing. Almost, if you think of it almost like a ride, it slows down right? Almost looks, it kind of evens out to like it's flat, crosses the x-axis, then it continues to go back up, right? Kind of almost increase in how quickly it goes up, right? But it does pass through it, right? And in fact, if I were to, let me change it to the next odd number, 5, it has that same general behavior, right? And again here, if I do this to b, right, when I make it odd, right, it has that same, comes down, almost flattens out a little, kind of, and then continues to pass through the x-axis. Okay. All right. Okay. So what we see here is these roots have a multiplicity, right? When the multiplicity is 1, right, it almost behaves like a line. It just kind of goes right through the x-axis, right, like we see here. And actually, let me let's do this. Okay. All right. So here, when it's even, right, it does this, bounces off the axes and goes back in the direction. When it is 1, right, it kind of behaves like a line. It goes back through. And when it's odd, it kind of has this same kind of flattening out pattern and continues on its way, crossing the axes. Right, and whatever the multiplicity happens to be, so in this case, we would say x equals -1 has, the root has a multiplicity 2. The root at x equals 2 has a multiplicity of 1. And the root as x equals 3 has a multiplicity of 3 as well. Okay, so now we've seen how the multiplicity of these roots affects the behavior at the x intercepts.